This is Ivan Signorelli from Ocean Boardroom. We have another video for you today, and it's still regarding radar, as I promised in the last video. And we're going to be looking at how to use plotting sheets in order to help you in collision avoidance using radar. Now, a lot of people are going to say, oh, why do you need to do that? That's very old-fashioned, and nowadays we have ARPA, MARPA, all these different tools, and that's absolutely true. We're also going to have a video on how to use those tools, the advantage and disadvantage of those tools as well. However, knowing how to use a plotting sheet for radar is not only important in case your systems go down, such as ARPA or MARPA, but the other advantage as well is that allows you to get more proficient at using radar. You get better at reading the radar screen and being able to observe what's out there. Also, in the monotony of a passage, this can even be a little bit of fun as well. Keep the crew engaged and learn new skills as well. So I hope you enjoy it. This is a two-part series. The first part is we're going to look at how to do the WAO triangle for collision avoidance on a head-up or course-up mode. And the second part, we're going to be looking at how to do it on a north-up mode. All right, so hope you enjoy it, and I'll see you on the other side of the video. Asking us, assume that it's nighttime with visibility of about 2 miles. Your radar is operating on the 6-mile scale in course-up mode, which is similar to head-up mode. Yeah. For each of the following plotting sheets, firstly, assess whether there's a risk of collision. Whether you cross ahead of the contact or astern of it. What's the target CPA or closest point of approach? And which light will you see when the vessel first appears? Port, starboard, or overtaking? Remember, you got about 2 miles of visibility. And what's the target's course and speed? So we want to answer all those questions for each one of these problems here. I'm going to write down my own speed is 6 knots. And my own course is 040 true. These are all true, by the way, so don't worry about true or magnetic and that sort of stuff. Cool. The next thing we're going to do is, this is the more tedious bit, is we need to transfer. We're going to have to transfer these marks from the plotting sheet here to the actual plotting sheet that we have that we're going to use. So we don't have to. You can be pretty pragmatic about this, right? So once you've plotted all these three, you notice that they should be somewhat in a straight line. And what we're going to do is, firstly, I want you to notice something. Notice that each mark is how many minutes apart?
6 minutes.
6 minutes. Yeah. So the reason why you use 6 minutes or maybe 12 minutes, it's for convenience. Yeah. 6 minutes is really convenient because it's 1/10 of an hour, which is going to make our life a lot easier when we go to calculate speed. Okay. So even if you're going to do this for real, if you ever do, try to if you're going to track a target, try to track the target every 6 minutes. It's just going to make your life easier later on. Yeah. So the next step we're going to do here is we're going to take a ruler and we're going to draw a line connecting the 3 points. And I'm going to start at the first and draw it all the way through to the end, like that. So the first thing that we want to answer after drawing this is there a risk of collision? What do we think? Nat?
No.
No, right? Because remember, the bearing is changing. We were at 305. Then on the second one, the bearing was 310. Then on the third one, the bearing is 325. So really, we're not on the risk of collision here. Yeah. But then we want to find out how close are we going to pass to this particular target. Okay, so we're going to calculate its CPA. And in order to calculate the CPA, what we're going to do is we're going to find the point on this line using our ruler. We're going to put the ruler at 90 degrees to that line like this. So we want a 90-degree angle here. And then I'm going to shift the ruler down at 90 degrees to that line until the ruler goes to the middle of the plotting sheet like this. Just like that. And then what I'm going to do is I'm going to draw that line there. So this is a 90-degree angle here. So in order to calculate the CPA, what we're going to do now is we're going to measure this distance here. Take your dividers. Whoops, a bit of a tangle here. You're going to take your divider and you're going to measure from the center to this point, to that line, just like that. And then you're going to use that. There's a scale. Notice there's a scale here.
Oh, yeah.
Where?
Here, almost.
Oh,
Yeah.
Yeah, so on that right part there, on that horizontal, right part of the horizontal line, you're going to measure the that distance. So I'm getting about 1.3 miles. If you got anywhere in the vicinity, that's fine. So that's our CPA. That's our closest point of approach. It is about 1.3 miles. That's the closest we will get to this vessel, given their current course and speed and our current course and speed. Of course, that can change if we alter course and speed, but for the time being, that's going to be our CPA. So now, there's a couple more questions we need to answer. Will it cross ahead the contact or astern of it? Before we answer any of that, we need to find what's the target's course and speed, right? And this is where it's going to get a bit interesting. We call this the WAO triangle. It's called the WAO triangle because we're going to label different parts of this line. So where I have my first mark, I'm going to call this the O. I'm going to label this as O, as in Oscar.
the what? Oh.
So this one is going to label O as in Oscar.
Oscar.
And the third part here, the third mark, I'm going to label that as A as in Alpha. So just put the letters there. It will make sense in a minute why we use these letters. All right, so in order to find out this vessel's course and speed, what we're going to do now, we're going to do this triangle. Now, one of the important things is we are in course set mode. Yeah, so we can draw our little heading line here, our little course line here. So that means that our vessel is traveling along. So let me get my boat here. Our boat, because we're in course set mode, our boat is traveling along this line here. Okay. So what we need to do is we need to draw our course on the plotting sheet. Okay. And where we draw this course on the plotting sheet is from the first sighting of the target. Okay. And what we do is we draw the reciprocal course because remember we're moving in this direction. So we want to draw the reciprocal course to what we're currently moving. Okay. So this is pretty easy because we're going in this direction here. The reciprocal course is going to be straight this way. Yeah, because remember, we're in relative motion. Everything is moving relative to us. We're always at the center. Cool. So what we're going to do is we're going to take our ruler and we're going to draw a line that's going to be reciprocal to our course. And don't worry about the distance yet. I'm going to show what we're going to do about the distance. I'm just going to draw it all the way down to this line here. Okay, like that. All right, so the next thing we're going to do now is we need to determine how far we have traveled in this 12 minutes. Yeah, from the first, since the first time we saw the target to the last time we marked the target. So it's been 12 minutes here, hasn't it? Yeah. So we need to determine how far we've traveled in 12 minutes. Yeah. So this is where using 6 minutes is quite handy. If my speed is 6 knots, how far did I travel in 6 minutes? So if my speed is 6 knots, how far did I travel in 1/10 of an hour, in other words?
0.6.
Yeah,
6 knots.
that's it, Barry. Yeah, you travel 0.6 miles. Yeah. So because we're looking at a 12-minute time period here, then therefore we traveled a total of how many miles? 1.2. Yeah, does that make sense? So what we're going to do now, guys, is we're going to take, again, our divider. We're going to measure 1.2 miles. So take a divider, measure 1.2 miles here. And what you're going to do with this is we're going to mark those 1.2 miles on that course that we drew. Like that. This part here, where we drew this mark, we're going to label this as W, whiskey. This is the W here. Step here is this, guys. What the next thing you're going to do now, you're going to take your ruler, you're going to connect W to A. You're going to connect W to A, and this is why we call it the WAO triangle. So one way of looking at this is WO is way of my own vessel. WA is way of another vessel. Yeah, so that's one way you remember. WO is way of my own vessel. WA is way of another vessel. Oh, once you've gotten to this point, now we need to work out the other vessel's course and speed. All right. So what we're going to do now is, in order to work out the other vessel's course, you're going to take your plotter or parallel rule, whatever it is that you prefer to use, and we're going to work out the bearing of this line here. Yeah, using a plotter. Go and work out the bearing, and I'm getting 90 degrees as that bearing. Now, once you've taken the bearing, remember that's your relative bearing. Now you need to find the true bearing. So the true bearing, remember, is going to be the relative bearing, which you just worked out to be 90 degrees, and you're going to add your own heading, which is 40 degrees. And that's going to give you the other vessel's course, which is going to be 130. Yeah, 130 degrees true. That's the vessel's course. Then the other piece of the puzzle is going to be to find its speed. Ready to calculate speed? What you need to do is you're gonna measure the distance from W to A. Give us, what do we get here? We have about
3.
Yeah, we have about
4.5.
3.4, right? So now, what does that mean? It means that in 12 minutes, this vessel covered 3 miles. Yeah. So what was its speed? So 3 divided by 0.2 will give you its speed.
Why did you use 0.2?
Because 0.2 is 2/10 of an hour.
Oh, yeah, okay, right. Yes,
Yeah.
Got it.
Or 1/5. Yeah. 15 is correct. Yeah. So 3 divided by 0.2 is 15. Yeah. All right, so now that we have the vessel's course and speed, we can it kind of becomes easier to tell what's actually happening here. So my course is 040, and the other vessel's course is 130. So if I take two boats here, I'm moving at 040 at 6 knots. That's me there. This is in kind of true motion, by the way. If the other vessel is at a course of 130, it's coming from, I'll just put my boat here. I'm at 040, moving at 6 knots. The other vessel is at 130, moving at 50 knots. 130 is here. Yeah. So what's happening here is this. I'm moving in this direction. Boom, boom, boom. This vessel is moving in this direction, but much faster than me. So you can see how it's going to pass in front of me, yeah, because it's moving fast, yeah, like that. So if we try to answer the other parts of the question is, will you cross ahead of the contact or astern of it? What do we think? You're going to go behind it? You're going to pass behind it or in front of it?
Behind.
You're going to pass behind, yeah? And what light will you see when you first see it? So
Green, starboard.
you're going to see the green starboard light, yeah. Okay. Good. So that's how you work through this problem, yeah? Guys, that's how you do the WAO triangle on using a head-up mode. I hope that made sense. It can be a bit tricky sometimes, especially because radar uses relative motion. But nevertheless, I hope that you can now feel a little bit more confident about using a plotting sheet, and in order for collision avoidance and avoid those radar-assisted collisions that sometimes happen out there. Part 2, we're going to look at how to do it in north-up mode, and we're also going to talk about MARPA and ARPA and different tools for collision avoidance that exist already within radar. That's a little bit easier than using the plotting sheets, nevertheless. So I'll catch you on part 2. Remember to subscribe and like the video, and leave your comments if you feel like you have any. All right. By the way, notice I'm wearing a hat because my hair is just out of control with this lockdown in Sydney. There's no haircuts, so yeah, we're looking a bit rough, but nothing like a hat to hide that. So thank you guys, and we'll see you next time.